Steelmaking, Warren's Way. LTV Steel's Warren Coke Plant is a 4-meter Koppers divided type battery consisting of 85 ovens, which began operations in 1979. This is the only battery in the United States utilizing a computerized combustion control system that automatically regulates individual oven heating, providing such benefits as high-quality coke, improved yields, lower fuel consumption, and enhancement of environmental control. 2,200 tons of coal are baked daily at 2,400 degrees for approximately 17 hours. With the cycle complete, coke is pushed from the oven. Warren produces over 1,500 tons of high-quality metallurgical coke daily, which is then quenched, unloaded to conveyor belts, and transported to the blast furnace. The modern byproducts portion of the plant cleans and refines the coke oven gas for use throughout the Warren Works and produces various products such as tar, light oil, sulfur, and ammonium sulfate for outside sales. The coke plant, through employee management participation, successfully implemented the statistically based integrated process control program. According to the corporate audit, Warren Works Coke Plant is #1 on the company ratings over the last 2 years in IPC implementation. The Warren blast furnace was completely rebuilt in 1981, using the latest design equipment and technology. In 1984, a new brick lining was installed, which is presently over 1/2 its original thickness. An ongoing preventive maintenance program keeps the furnace in excellent condition while producing all the molten iron required by the Warren Works. Sitting atop the blast furnace is a unique charging system, incorporating a revolving chute instead of bells to distribute the raw materials inside. The charging system, together with a vast array of monitoring equipment, is entirely computer controlled, providing optimum fuel rate, minimal refractory lining wear, and the production of high-quality iron. Warren employs the newest technology for unloading and stockpiling iron ore pellets with a rotary railroad car dumper and a towering stacker reclaimer. Both cast houses are equipped with air pollution containment systems and a bag house. A new water treatment plant was built in 1983. Environmentally, the furnace complies with all EPA requirements. Over the past several months, the computer equipment, high-quality coke, and new natural gas and oxygen injection techniques have helped break all previous production records, resulting in the rated production capacity of the furnace and the entire Warren Works to be increased by over 12,000 tons per month. Warren's 2-vessel basic oxygen furnace replaced 8 250-ton open hearth and 2 250-ton electric furnaces. The BOF produces steel with carbon contents from 0.015% to 0.85% at the rate of 140,000 tons per month. Warren specializes in electrical steels, high carbon or low alloy steel, each of which may be supplied with ultra-low sulfur and very high internal quality. The BOF's computer is the nerve center of steel making in Warren. Linked to the chem lab equipment and computers at the data center, blast furnace, and coke plant, it calculates the weights of hot metal, recycled steel, fluxes, and the volume of oxygen needed to meet the weight, temperature, and carbon specifications of turned-down condition. It also accumulates information on all expendable plant materials and equipment, assuring maximum utility. A quality system functions best with mutually determined and agreed standards. Each area is studied with standards written by personnel on the jobs. All areas are monitored by charting, with variations explained. Action is taken or standards are revised, resulting in an efficient standard operating procedure for every process. This in-house designed desulfurizing station removes sulfur from the iron by injecting a magnesium calcium carbide mix. Warren's unique charging ladle dam design prevents slag from entering the vessels and lowers emissions during charging. The precipitator, an air cleaning system with a volume of 650,000 standard cubic feet per minute, removes over 99% of the particulates generated during steelmaking. This efficiency is a credit to BOF IPC implementation. The in-house designed bottom stirring system uses argon and/or carbon dioxide to agitate the bath while top blowing with the oxygen lance. The stirring action makes steel faster by increasing the oxidation and slag making processes. And by lowering dissolved oxygen contents, there are less inclusions and more efficient and consistent alloy additions, producing higher quality steel. X-ray and spectrographic analysis is performed before tapping and after alloy additions. Dissolved oxygen and temperature measurements are made simultaneously by a metal-metal oxide couple. The original design of Dr. Fitterer was tested and refined in Warren. Tapping a heat is the art of steelmaking. While new ceramics help the melter maintain the stream's shape, a trained eye is the best tool of an efficient tap cycle. Ladle metallurgy, performed after tapping, is classified as homogenization, rinsing, wire feeding, or powder injections. Two methods are employed: composition control, chemistry and temperature, and inclusion control, reduction of the size and type of inclusion, and/or modification of their type, shape, and composition. Operating and masonry personnel and refractory suppliers using IPC methods have successfully improved steel quality and ladle life by providing clean ladles and advancements in refractory practices, maintenance, and steel valve technology. This ladle preheater minimizes thermal shock to the expensive alumina and magnesia refractories. Clean molds are the beginning to a high-quality ingot surface. Mechanical flailing removes any large deposits. High-pressure washing removes the entrapped dirt. And as the molds age, grinding ensures a smooth surface. Through computer modeling, Warren personnel designed an optimum shape for ingot bottoms, increasing slab yield by as much as 3%. Bottom pouring fills several molds at once, isolated from the atmosphere with minimum turbulence at a slow, regular rate. Bottom pouring improves slab surface and internal quality on high carbon, low alloy, and surface critical grades, allowing the Warren Works to compete with cast product. The Warren Works 36-inch slabbing mill is the combination of the blooming mill and steel conditioning yard. Arriving ingots are stripped and charged into the pits for reheating. New computerized processor controls provide a 50% fuel savings, giving Warren the most efficient soaking pits in the industry. As ingots reach their required temperature, they are sequenced into the data center computer, informing the crew to ingot size, slab size, grade, analysis, and any special instructions. The roller applies both flat and edging passes, shaping the ingot into a slab. Special attention to specific shearing practices is resulting in great yields, averaging over 92%. Slab size is checked regularly through communication with the sizer identifier. A new computerized tagging machine will soon complement Warren's accurate slab identification system. On surface critical grades, slabs are sent out for grinding, ensuring a flawless surface. Modifications to the cranes, widening the shears, a 20% increase in the mill opening, and a strong new intermediate table allowed ingot enlargement from 25 by 41 inches to 30 by 54 inches, or 20,000 pounds to 35,000 pounds, a phenomenal 75% increase. Maximum slab size is now 50 by 7 inches. Warren's Slabber currently has the highest integrated process control score in LTV Steel for blooming slabbing mills. Warren Works 56-inch hot strip mill receives slabs from a variety of sources, primarily the slabber, which are inspected, weighed, and charged into the continuous gas-fired 3-zone reheat furnaces. As slabs reach temperature, they are pushed out onto the table. The vertical edger controls the initial width, and the scale is removed by the scale breaker. The 2-high roughing mill begins the transformation from slab to strip. Warren's 4-high reversing roughing mill, its vertical edger, tables, and descaler are all fully computer controlled, with the installation and programming done entirely by in-house personnel. The front of the slab is sheared and fed into the 6-stand finishing mill. The balance of the slab is kept hot as it moves along the holding table with new covers and insulated roll separators. The holding table covers are a Wien design, modified by in-house engineering. Warren's 56-inch mill now has higher yields and rolls thicker slabs in larger coils. This heat retention saves energy by lowering reheat temperature while expanding product limits through finer gauge control and more uniform physical properties. The strip moves through the 6 finishing mills at speeds up to 2,500 feet per minute, meeting strict temperature requirements when exiting the last stand. Final gauge is regulated by a hydraulic wheeler automatic gauge control system. Inputs are signals from load cells measuring the force at 5 of the mills, and gauge after the last stand. This system's excellence is a credit to in-house personnel and provides Warren's hot roll customers 1/2 standard tolerance on all carbon grades and 2/3 tolerance on alloy and high-strength steels. Upon leaving the last mill, an X-ray gauge, infrared meter, and pyrometer record the strip's gauge, width, and temperature. Entering the strip runout table, a select number of shamming water curtains cool the top and bottom evenly. Many in-house modifications include the soon-to-be completed computer automation of this system. Proper strip cooling rate is imperative to achieving excellent physical properties, grain size, and surface finish. The strip is coiled at one of 3 coilers for band, strip, or sheet products. The coil is inspected, banded, weighed, and shipped to the customer or sent on for further processing. Mechanically sound and high-powered, the 56-inch mill produces a wide variety of steels, including structural and high strength, alloy and high carbon, plain carbon, stainless, silicon electrical, and nickel alloy, with gauges from .053 to .565, width from 15.5 to 50 inches, and coil size up to 72 inches. The feedback of high carbon and alloy customers proclaims this LTV mill's crown control excellence, makes it the best producer in the United States and of world-class quality. The Warren Works Rolling and Finishing Department, a combination of hot strip finishing and cold strip finishing, consists of 2 pickle lines, 2 slitters, 2 temper mills, the tandem mill, and the portable anneal. The pickle lines receive hot band coils primarily from the 56-inch mill, and applying the newest technology, butt weld full cold reduced strip ends, producing larger coils. The number 5 pickler specializes in high carbon, carbon alloy, and silicon steel from 14 to 38 inches wide. Number 6 pickler processes low carbon steel from 18 to 48 inches wide and utilizes an inline temper mill, controlling flatness and surface finish. Warren slitters cut up to 19 multiples on coil widths from 2 to 49 inches and gauge from .065 to .250. Number 52 temper mill accommodates flatness and physical requirements on coils up to 49 inches wide. The 4-stand tandem mill cold reduces pickled coils to near final gauge, controlled by a quick response hydraulic system. Integrated process controls have maximized strip cleanliness by improving the rolling solution tested meticulously in the rolling and finishing lab. This video screen at the roller station displays any variation in strip shape through transducers mounted in a segmented roll, measuring tension at 2-inch intervals. Warren's stressometer flatness control system by ASEA Metallurgy is the first installed in a United States steel facility. The portable anneal is an extremely efficient batch anneal process consisting of 114 single-stack bases. Computer controls generate the cycles and maintain temperature within 1 degree of set point. After annealing, cold rolled coils are temper rolled to final gauge. Warren's number 54 temper mill is a single-stand 4-high mill. A full roll bending crown-out system is set in motion, assuring excellent shape and temper elongation control. Warren's coated products department consists of the turn, galvanized, and silicon lines, the roll former unit, and 48-inch slitter. The turn line is one of only 3 in the United States, and turn plate has the best profit margin of all products manufactured at the Warren Works. The strip is cleaned, pickled, and hot dipped in a lead tin alloy. Widths range from 20 to 48 inches and gauge from .015 to .070. Turn is coated in weights of commercial LT01 to LT50 and is applied primarily to gasoline tanks. The Warren galvanized line processes widths ranging from 20 to 48 inches and gauge from .019 to .160, with coatings from G01 to G310 in regular spangle, minimum spangle, and extra smooth. A hair boss leveler enhances the shape, delivering a deeply drawn flat product to customers. Warren's silicon continuous anneal line is an 1,114-foot horizontal furnace, which anneals and coats non-oriented electrical steel. The line processes fully reduced cold bands with silicon contents from 0 to 3%. Widths range from 18 to 48 inches and gauge from .014 to .037. Continuous annealing develops uniform and consistent physical and magnetic properties, with 24 independently controlled heating zones. An in-line coater applies several types of uniform core plate coatings, and all steel is tested with the magnetic characteristics certified. The Warren Works silicon line gives LTV Steel industry leadership in capacity and marketing of electrical steel. The bottom line for 1986 was a return to profitability, making it crystal clear that Warren works.